Hello, hello, hello. Hello, hello. Hello, chat. Hello. Just wait a second. Let me paste the link in the Discord. Hmm. Hmm. Hello, hello, hello. Hello, everyone. This is the day 37 of my C++ DSA journey. In today's stream, we will be doing some new problems based on binary search. Okay, like we will apply binary search on an answer if that answer is valid or not. We will apply a binary search according to that. And also we will revisit some problems based on binary search in which we also have to apply binary search in that. Okay. Like the questions we done yesterday, today we will take the questions in which the opposite of it will happen. Like yesterday we did the problem in which we found the minimum of maximum, right? So today we will solve the questions in which we will have to find maximum of the minimum. Okay, like the maximum in the minimum, right? So today we will do the aggressive cows problem, and there is also another same problem on elite code. That's name is that's name is magnetic force between two balls. It's similar to aggressive cows problem, which will be on Geek for Geeks. Um, Wait. Hmm. And yeah, I read the statement of painter's partition part second, but it was same as painter's partition in Geek for Geeks. I think it is just misprinted. So instead of taking that, I will be taking this problem, okay, which is on lead code. And yeah, we don't have to take so much problems of the same type just to reinforce the pattern and for that we will like take the opposite problems with the opposite pattern. Like we will do two versions of that. So first we will do new problems based on the opposite in which we have to do the opposite of what we have done in yesterday, right? So okay, aggressive. Oh wait, hold on. Aggressive cows. Let's see, it's on Geek for Geeks. Okay. Like in this problem, we have to. Okay, first I will write the code. After that, I will explain what's given in the problem or what we have to do. Like in this, just we have to return the maximum of the minimum, minimum distance. Like there will be some cows, those cows are aggressive, so we have to uh, put them at a stall, like at a distance which is more than or equals to given allowed limit. Okay, it should be more than or equals to allowed limit. Then it will be a valid answer. So first we will apply binary search, right? First we will write the code for binary search. After that we will write the code on which binary search will be applied, right? Okay, wait. So what we have to do first, like we will first pick the range in which the answer will be. So for picking the range, what will be the range? Um, like there will be minimum two cows, like which we can place. Okay, in this stalls, there should be minimum of two cows. Okay, and okay, let me read the statement. Given an integer array, there is an array given which denotes the position of stalls. Okay, these are the position of stalls. It is showing all the positions are distinct. Okay, all the positions are distinct, different. There are k number of aggressive cows. So we have to assign the cows to the stalls such that the minimum distance between any of the two cows is maximized. Okay, we have to return the maximum of the minimum distance between the cows, right? So for that, okay, we will apply binary search in that. And the search range will be like there will be the first cow will be we can place it on the very first index, right? By default it will be on. So we will create a start variable with the first, okay, one, right? The range will start from one and go till like we can place, suppose there is only two cows, so we can place the first one here and the last one on the n minus one index, right? Like the last index. So we can initialize end with, okay, n minus one. I will change the things in this, like how like I have not initialized n, but there will be a point where we will also sort this array. After that, this will make sense. Okay. Start and end. Okay, fine. So while start is less than or equals to end, right? We do this. Then after that, we calculate the mid by, okay. We also have to have an answer variable in which the answer will be stored, right? Then we will check that in which side of the array we should go so that we maximize the minimum distance in, yeah, in between the cows, right? So that like we have to return the maximum of minimum distance in this. So mid is equals to start plus, I will maybe yeah, I will do the dry run in Excalibur also because this problem will be similar, like this problem will be similar to this, so we can do the dry run on it, right? This, there is a visual representation of this is given here. um, we will see that. Okay, we calculated the image. First we get the starting and end point, the range, and we calculated the mid. After that, there will be two conditions. If now there will be function is valid. Okay, I will name it as is valid. If it's valid, then we have to do what? Then we have to initialize the answer, like overwrite answer with mid. Okay, answer will be equals to mid, and yeah, answer will be equals to mid, and then we will search for the bigger values, and bigger values will be in which side of the array, you think? Like we get a range, so the bigger values will be, and the range is already sorted, so the bigger values will be in the right side, of course. So we will start reinitialize start with mid plus 1, right? Like we have to search for it in the right side of the array. Then suppose if it's not valid, like in the else case, if it's not valid, so in that case we will go in the left side of the array. Why? Because those will be that will be a value which is bigger than the in which from which we can allocate the cows, like stalls, right, to the cows, in which we can place the cows in the stalls. So end is equals to mid minus 1. Okay, this is the code for this, and in that we will return wait. Yeah, after the while loop we have to return answer, and before this we will write the that another variable. Okay, this is star mean dereference. Okay, wait. Constraint are given like this. See, binary search will be applied. Let's time complexity big of n log m. Okay. So now we will create the yeah, in this function we will pass the value of array and number of stalls and number of cows and mid, right? Okay, wait. Yeah, number of cows will also be passed. Now we will create a variable function, boolean type function to check it. Bool is valid. And now we will pass those here. Don't know if this dereference operator will be here or what. Maybe it will be here. We will check if it will not run. Then maybe we will remove this dereference operator, right? So here we will pass like we will here we have passed mid, but we will allow, named it as max allowed distance. Oh no, not max allowed. It will be minimum allowed distance. The minimum allowed. I will name it as minimum allowed. Then inside this, what we will do is, yeah, we have created this boolean function. We will start with the first cow, right? The starting cow will be 1. Okay, 1 and the first cow will by default will be at the 0th index, right? Like the very first stall. So it is this. And now there will be a condition if first cow is already placed at this stall. Okay, the very first stall. Then we will place the other cows, right? So for this, yeah, we also have to use a for loop here. Traverse the whole array for integerize the I less than nums. No, not nums. It is named as array, right? I less than array dot size I plus plus, and you see that you can see that the this is not in a sorted manner, right? Like the stalls are not in a sorted manner, so we will bring that in a sorted manner. Like we can bring it in a sorted manner here, right? So sort array dot begin and array dot end. So by doing this, we have sorted the array, right? Now I think this will work because in the lecture the ma'am has told us this will work, right? Like I think after writing a function, if we initialize the values like this, maybe it works, right? So we will check for that also. And inside this, there will be a condition. Wait. Uh, yeah, and it will start from the second value, right? Because we have already initialized the zeroth index, like the first stall to the cow. So for that, so inside this, there was a condition that, mm, yeah, array index. Just wait a second. Just wait a second. Let me see what was that. I'm like, forgetting a little bit. Mm, okay. Yeah, the syntax of that was L minus one, right? Not N minus one minus array at zero position, right? So we subtracted that. So the condition was like array of 5 plus the last stall, not last stall, okay. Array in minus last stall value. Like these values are representing the stall number, okay. These values are representing stall number, and this is if this is more than or equals to maximum, okay, it will be inside this bracket. Wait, more than max allowed, more than or equals to max allowed, okay. Then we will do what? We will increase the number of cows in that case. Okay, so cow plus plus. Every time this happens, and we will name it as cows, right? So cows, because there will be more than one cow. So cow plus plus, and last stall value will be equals to current index value of array. Okay. Yeah, like we are subtracting indexes, right? Like the last stall index with the current stall index value, and we'll check if it's more than or equals to max allowed. If it's more than or equals to max allowed, then cow plus plus and stall last stall will be reinitialized, will override with this value so that we can check for further. Okay, this is done. Then position. Yeah, and in that we will check if return if cow is more than or equals to, no, if it's equals to k, right? Number of cows in the original. Return cows. We have to return true if cows is equals to number of k, right? Mm, what? Wait, let's just let me. Oh, sorry, this was just my mic was closed. I was just let me see from which. Okay, I think it's been off for the past 3-4 minutes. I was supposed to like close the display when I was logging in. Instead of that, I switched off. Yeah, turned off the mic button. Not a lot of clip video has been gone, so yeah, we will understand it also. Yeah. Sort array plus. Okay, we'll do that as a pointer. Sort array comma array dot n. You will be have to sort it like this. Mm, okay, array plus n. Mm, and inside the loop we will use an vector style. Now tell me where are the syntax like in between when it was off. I was just writing the code for this part like the valid function and just checking like where the syntax error. Now tell me where are the syntax errors. Okay, these are the syntax error. Yeah, we have to comparison of it. Um, oh, wait. There are some mistakes. N minus star divided by 2. And but we don't know more than or equals to, right? Why it is given like more than or equals to? Assignment instead of comparison. Sort array. Use this. Okay. Saying that if you use that, it will be compiled. In function aggressive cows, reference to sort. It's giving some error. We have to include this also. Or do we have to place this in the very, yeah, in the very top it will be right. Okay. So I will give the code to it also. Maybe these lines will also be added. Okay. That means platform C file driver. It's using C file driver, driver.c and C compiler. Okay. Uh, dot cpp, not dot c. Oh man, it's in C. Uh, where is the code gone? Okay, I will copy the code and we were supposed to write this in C, right? Just wait. And I think maybe in C. Hello, hello, hello. Welcome to the stream. Okay, in this you can all see that we can remove that, right? So I will just paste it here inside this. Okay, not inside this, maybe after this, right? And we will copy this, and instead of this thing, we have changed the things. Now, yeah, I will remove this. Hello, hello. Okay, now we can sort the array like this array dot begin, comma array dot end, right? And now we can do here is array dot size, and there it will be removed. Mm, uh, okay. And mistakenly I use hello. Why are you very silent, ma'am? Sorry, Java, I'm going to use not used wrote the code in C. Yeah, yeah, it happens sometime. How was your day, Aaron? Okay, let me fix that. We will copy this. Yeah, we have to also change this because in the previous function we haven't done that. Oh, oh wait, wait. I'm super. Oh, it feels like I think today you have done around so many problems, right? Or have you started any new topic? Loop condition. Yeah. Return statement. Aggressive couch functions parameter. No. Like you said, it was super. Then what was the thing that like you felt after that, okay, today was a super day for me. Okay, we will have to write that. I think ma'am was write that to the show. Right. Okay, I will create that. Just uh, right. Calling is invalid. But I mean, let's see where will be. No, no, like you said that your day was super. Then, like, what was the thing that after that you felt that okay, today is a super day. I will mark it as a super day. Like, have you learned something new, or like got some good information today, or something good happened to you? Now, oh, actually, I started to making another oh project. So that project was ended, like in on which you were working, right? You were working on a project, I think 3 or 4 days ago. Is that completed? Valid parameter. No together. Oh, you are working on two projects simultaneously, right? So what is that project about? Like, so what is that project is about? Uh, will we will get to see some interesting thing in that or redundant? Yeah. Oh wait. Semicolon. Calling is valid. Focusing on only coding, computers, teaching. I didn't understood like what you are saying. Are you talking about yourself or me? Mhm. Yeah, instead of and we can just pass this, right? I- Wait. Okay, we will have to pass. Have you done is perfect square on LeetCode? No, I haven't done that. But the name is Wait, what is perfect square? Hmm, LeetCode. A valid perfect square, right? Hmm. Num is a perfect square or false. So the perfect square is an integer, that is square of an integer. Hmm. Oh, okay. Yeah, we can do this. Okay, body such. We can do this later. Okay. So in this, we will have to pass that parameter also. Oh, wait. Array. Oh, okay, here, right? Array. Mm-hmm. Okay, it's accepted, man. Case complete. Completed. Compilation completed. Okay, our code is running. Um, wait. Let me show it to the Copilot. It compile and give right output. Okay. Okay, we have done the first problem of today. Name was aggressive cows. So I will submit it. Maybe it will fail here, right? Or oh, it's pass. It's pass. So do you want to like share a project on Discord or something? Like, have you finished any project? Like there was a guy who shared his project on Discord, like a HTML project, and after that he shared a JavaScript project in which he created a rock paper scissors game. You have any project that you want to share on Discord? Like we will see it. Like, um, how is that? 4 minutes. Do you feel that the streams are getting boring, or you feel that okay, streams are somewhat interesting? Like, do you feel good like having interaction with me or like seeing me solving problem or getting stuck in a problem and also at the same time giving words to the thoughts in my mind? Okay, this is done. Um, Dave, I have wrote the code, so I will now try to explain the code, what is given in the code and what fitting. Not boring, but it's actually too long. But yeah, for you good, it's good. Good. You know the thing you are asking about is on the day 34 stream. I explained the problem like that problem. Then this that problem like there were three similar problems like that, which I have done in this day 35 stream. Okay, you can check it. Check the stream. Okay, like I have also given explanation using Excalibur in that. Oh man, where is it gone? Wait. Oh, not in this stream. It is on day 36. Yeah, this stream. You know, like the whole explanation of the problem on extra draw yesterday. Okay. Yeah, here it was. On day 36, I explained the word problem, like what we have to do, how we will find a range, or on which thing the binary search will be applied, and what will happen in the binary search, how the middle value will work. Yeah, it was a very good stream. Like the yesterday stream was gone very in a very smooth way. So if you want, you can see the stream. Yeah, I will recommend that. Hmm. Uh, it got a little bit long yesterday, but from the past few days, it was not getting that long. But yesterday, I was supposed to like there was an objective which I have to complete. So I completed that in the you know before the expected time. Like I was expecting that like this will go far more than maybe more than 5 hours or maybe 6 hours. But it took less than that, and also I was able to solve another new problem instead of that. Like according to the course, the streams will be less, but I pick more problems, like try to do more practice or revisit the problem, or the explain the things to the viewers. So because of that, the streams time get stressed for because of that. If I was to just solve the problem, then I think it would have just taken 1 hour or 30 minutes, right? So we are not doing that. And this problem that I am going to solve now is the same as this, just the variable names will be changed and the things will be a little bit changed. Okay. Why we are doing this? So we will understand again, reinforce the pattern by self. First, I will explain what we have to do in this problem. Okay. Like what I have done. So there will be n number of cows. Okay. These cows are aggressive, so we have to place them in the stall. Like the stall will be sorted off when we will try to put the cows in a stall, and those cows are aggressive. Okay, so the minimum distance between two cows should be maximized according to the problem. Okay, so in this case, we have to return the maximum of the minimum distance between the stalls. Okay, in which the cows will be placed so that they not become aggressive, and if they become aggressive, they don't fight with each other. Okay, like this is the problem because the cows are very angry. For that, we wrote this binary search code, like the opposite of it. What we did in the problem yesterday, in which the name was book allocation or split array largest sum or painter's partition. In that, we check for the minimum of the maximum, right? But in this, we check for the maximum of the minimum. So, the opposite of that. Okay, first I created this variable named as num n, and it is showing the number of elements present in the array. Then I sorted the array because these are representing on which stall the cow will be. So yeah, we have sorted it in the sorted format. So this is done. Then after that, we applied the code. Like we found the range, and range will be the will be from the very first index to the last index, and then after that we take answer variable, right? And then after that we apply binary search like this, like we calculate the mid value, and every time if the function is valid, like if the answer is valid, then that case we will store that mid value in the answer, and also check for more bigger values for a valid answer. Okay, because we have to and maximize the minimum distance in between the cows. Okay, maybe mid was on a point where it is the minimum distance is 1, but after that, if it's a valid answer, we can check for other values further going in the right side of the array, like the bigger values, to find the bigger distance. The bigger the distance will be, the less there will be a chance of that the cows will fight with each other. All right. And suppose if it's not giving a valid answer, like the distance was not equals to or more than the, okay, wait, the distance was not equals to or more than the minimum allowed distance. Okay, if it's that not true, and in the end we get the number of cows less than that, then we have to return false, else we will return the number true in that case. Mm, like in that case, when we place the cows and the cows you know distance will be less than will be less than minimum allowed distance. And minimum allowed distance will be what? Minimum allowed distance will be the mid value that we have that we get after taking the starting and end and dividing it by, like in this way, getting the middle value, like dividing the range by that, and the range will be already sorted in this manner. The range is starting from the 1 and going till 8. Okay, because the distance between two cows will there will be minimum two cows. So maybe we place the first cow at the very first index or the last cow at the last index. So yeah, so 9 minus 1 will give 8, right? So we will go from 1 to 8, like this will be the range. So that's how this code is working. Now I will also explain this using a Scala draw maybe. But before that, I want to just do this again. In this, we have to find the maximum distance, right? Uh, in the universe Earth C-137, Rick discovered. Okay, there's a boy named Rick. He discovered a special form of magnetic force between two balls. If they are put in a if they are put in his new invented basket, Rick has n number of empty baskets. The ith basket is at the position. Okay, this is the position of the baskets. Morty has n number of balls. To distribute the balls into the basket such that the minimum magnetic force between any of the ball is maximum. So okay, 3, 2, 1, 2. Um, distributing the balls into baskets 1, 4, and 7 will make the magnetic force between pairs 3, 3, 6. The minimum magnetic force is 3. We cannot achieve a larger minimum. Okay, see, we have to return a larger minimum, right? Um, no, wait. I just want to cross check if this is the same problem. This is also the same problem as as aggressive cows. Okay, correct have both are there will be stalls. Suppose if it's given, we have to place k cows or balls. Condition, we have to maximize the minimum distance. Approach the binary greedy search. Greedy check. Okay, yeah. So time complexity of this log big of and log max distance. Okay. So what we will do, we will first, for getting the range, it will be, okay, we will create a variable. 1 to 3. If we see the array is already sorted, right? But here it is not sorted. 5, 4, 3, 2, 1. Wait. Log of n log m. So if that's the case, maybe we will have to sort the array. We will see, because we also did sort that in the other. So starting will be 1, and yeah, before this, we will create a variable n dot. Okay, instead of position, I will name it as this, right? I rechanged the name of the vector. So size and mm, start is 1 and end is equals to write the last value in the array. Not array, it is position, right? Position. Okay, wait. Post. I will name it as post. Okay. And after that, we got the range. Now we will apply binary search. While start is less than or equals to end, then what we do? We we calculate the mid start plus end minus start divided by 2. Then after that we check for two conditions: if is valid function. Okay, and inside this if valid function we will pass the parameters like post and number of m is okay, m balls, number of balls, and yeah, mid. Then if it's that's giving true, in that case, yeah, and yeah, there will be answer variable, right? So answer is equals to -1. Now if it's that's true, so answer will be equals to mid, and we will check for the bigger values, right? So the bigger values will be in the right side of the array, right? So for that, we will go start is equals to mid plus 1, right? And in the else case, if it's not giving the valid, if it's not giving valid, then in that case we will why there is so many braces, man. This is the function. The function ended here. The while loop is okay. While loop is ended here. Fine. Now we are on the right track, I think. In the else case, we were supposed to, yeah. After this, we also have to return answer in the end. In that case, if it's not that the case, then we will check for it in the right side of the array. Because if that will not be a valid value for the distance, then we have to take a smaller value in that case. And okay, this is done. Now we'll create a very function, Boolean function. Bool is valid. We also do have to integer post, integer m, and integer. We will name it as max, not minimum allowed, right? Like what we did name that previously. And inside this function, we will create two variables named as balls. And we have initialized with one at the index last basket Okay, I will name it as last basket is equals to post at the 0. Okay, like the very first ball will be placed at the very first index of the this, and after that we will check for the conditions if post index minus last basket, right? If that is if that's yeah. Oh wait. If that is more than or equals to max allowed, sorry, minimum allowed. If it's more than or equals to minimum allowed, then in that case, the number of bonds plus plus and also last basket, we will override the value of last basket with current index value, right? If this is the case, if this is valid, right? In the else case, what we do? Oh wait, just let me see if there was. Okay, there was not another else case, right? I just got a little bit confused in that, you know. And yeah, we also have to use the for loop, man. Where will the for loop for this? For I is equals to 1, I is less than, uh, I is less than post dot side and I plus plus. This will be the for loop, and this will be inside the for loop. Yeah, this thing will be inside the for loop, and after the for loop, we will return if ball says more than equals to m, right? Oh, the code will give error because of this. Let's see. Last basket. Wait. So scripted value is not an array, pointer, or vector. In the balls, last basket. Post 0 in it. What? What does this mean? Okay. If it's vector integer, uh, oh wait, man. This is cool. I'm writing for that Gauss magnetic problem. Okay. So what? And then okay. Mhm. semicolon missing. Oh yeah, post at 0. Post at 0 position, right? We also get to check like where the error was. Like there were some syntax errors, right? Wrong answer. It's passing one test case for failing this. Wait, man. It's passing one test case failing. Other why? Is there any syntax error left? Yeah, I just have to go to the washroom. So search string end. Oh yeah, we have to also sort the post, right? Yeah, yeah. I was thinking about that. Like what we talked about in the starting. So sort post dot begin comma post dot end. So that we will get the right answer, right? Okay, here will it be it will fail again because of the semicolon was missing. Start and come on, okay, it's accept. I will submit it. It's accepted. Now we will check the time complexity and come on, man. Okay, it's accepted. This is this time complexity of big of n log n plus n log d. Okay, I will see it after the break. Okay. Uh, wait. Second new problem solve. After the break, I will explain what is happening in the problem. 5 minutes break. Until the break ends, you all try to see and understand the code like what I have done in the code. Till the break ends, I will be back to the break ends. Okay. Hello, hello, hello. We are back. We are back. There was an emergency washroom. I was going to for that. Now the nothing we can explain the problem. Like what is happening in both of these two problems. Okay, like I have explained this not in a little detail way, but I will now explain this using as an example. Uh, because we have to do the revisits, right? So I will use the example of revisits for that. And what I will do, I will use that as example and also mark it as revisited. Okay. Now the first revisit will be done also by that, and I will use this as an example. Allocate minimum pages. Okay. Let's bring it here. Let's bring this, or maybe, uh, yeah, that will be fine. What if we uh, okay, this is looking good, but it's just a little bit of uh, we will keep it like this. So what we did in the allocate minimum pages, we've we initialize the max book like the maximum, like the book with the maximum number of pages, right? Which was this in this case, and we initialize a sum with the in sum we add all the books, right? Like we only give one book to one children, or give all the books to one children. Okay, in that case we created this, and there was a sum. Sum includes all the book where page numbers. Okay, there are four books and it's four numbers. Then we get a valid range, like we get a range in which the possible answer may be present in that, like excluding the starting and end, it will be present inside that in between. Okay, like what we did here, the range will be like this. For in this example I have told you about. Okay, books should be allocated in a contiguous manner, like if we allocate the first book to the first student and second book to the second student, then we can't allocate the third book to the first student again. It should be in a sequence. Okay, so if you want to do that in a sequence, you can allocate first book to the first student or second book to the first student, and after that you allocate the third book to the second student. Okay, what we did in this problem, we get a range. Okay, we find a range and also check format if it's a valid answer or not. We allocate the books according to the mid, and mid behaves as the maximum allowed pages for a student. Okay, if it's more than maximum allowed pages when we give books to the students, then we pick another student for that and check for that. And if in the end the student's number is equals to the number of original students after allocating all the books, we return as a valid answer. Then we check for another shorter answer, like the shorter value from it. And again, if it's invalid, then we check with start is equals to mid plus one, right? So then we check for this value again, and if that's valid, then we will override the answer with a smaller value, because in this case we were supposed to return the maximum minimum of the maximum, right? That's what we are doing this here. Like we get the mid, and if it's valid, then we override the answer with mid, and again keep checking for more shorter values. Maybe allocation will be possible in that format, right? And in that case, if that's not true, then we check for it in the right side. No, yeah, right side of the array means checking using bigger values for that, because allocation will not be possible by using that value. So it will be possible by taking more bigger values, right? I've explained this to you in the previous stream, like the day 36 stream. If you go and see, this is all been explained there. Okay. But I will mark it as visited. And for checking if it's valid or not, we create this function and allocate the books using this. Like there will be a first student Okay, by default, we take one student, the first student, and pages is this. Then we check if current value is more than or equals to, okay, if it's more than maximum allowed pages, means if a single book number page single books page numbers are more than the maximum allowed pages, okay, even if that is case, then we will return false, because in that case we will not be able to allocate the books according to that, right? And if pages plus nums I value is less than or equals to max allowed pages, then we will assign that pages to the first student, right? In that case, if it's more than maximum allowed pages, then we will take another student by doing student plus plus and initialize and give reinitialize override pages value with this, and again keep checking for that until we traverse the whole array and all the books have been allocated. And in that we are checking if it's after the end, we check if students are equals to the original number of students to which we have to allocate the books, right? Um, this is how the code is working, and in the end we are returning answer in this after this binary search, where we have used binary search. So, and for range, I wanted to know how we will get the range. And you can see there is a base check that if maybe number of students is more than the number of books present, then in that case we will return -1. Okay, we will return -1 in that case, means allocation is not possible directly. I will submit it and mark it as revisited, but the variation, like the same problem of it is on LeetCode, so we will revisit that. Okay. Um, and yeah, we did use long function in this because it was suggested to use in this case, because on Geek for Geeks, its saying test cases are generated such that answer always fits in 32-bit integer. But when we will do that on LeetCode, we will don't have to use that. We can use simple int data type for that instead of, okay, it's marked as revisited, I think, right? Let's see. Correct. 790. Okay, today is 19th of July, 2026, right? Correct. Okay. Aggressive cows. And what we do in this problem, like the opposite of it is this, okay, magnetic force between two walls, or you can take aggressive cows, right? What we do in this, we apply binary search on answer again, but this time uh, we have to do the opposite of it. Instead of giving the maximum of the, oh sorry, minimum of the maximum, we give the maximum of the minimum in this. Like we try to get the maximum distance, right? Maximum of the minimum distance, we try to get the distance as far as possible. Like we have to place the cows into stalls so that the distance uh, should be the maximum, right? For that we use the binary search, so we get the range, and range will be, we will by default the first cow will be on the first index. Like suppose there is a case, the cow will be on the first index by default, and minimum of two cows will be there, because if there will be one cow, there will be no aggressiveness, and aggressiveness will be shown by him, that cow. So for aggressiveness, checking aggressiveness, we take two cows, right? At least we should have two cows. So the first cow can be placed on the first index and the last cow can be placed on the last index. And we get the range by this, like start with the very first index, okay, very first stall. Okay, this is representing that. And n is equals to n minus 1 minus the value at this, means 9 minus 1. Okay, so we get the range like from 1 to 8. And also we sort the array because we sort the array so that the stalls will be in the right manner in which we have to allocate the cows to. Okay, in which we will place the cows in a right manner. And after that we apply binary search, like we take an answer variable also. Then we apply binary search on that, we get the mid value, and we create a is valid function as we did in allocate minimum pages or split array largest sum or painter's partition problem. But in this, what we do, if it's a valid answer, okay, if it's a valid answer, we override the value of answer with mid and we check for bigger distances, like we have to maximize the minimum distance, right? So in that case we check for bigger values in the right side of the array because the range is sorted, and when the range is sorted we will find the bigger values on the right side, it's obvious. And in that case, if it's not valid, then we will check for the value in the left side of the array, like in that case in which we get the middle value. And if it's not, if we are not able to place cows according to that distance, okay, because that will be bigger than expected, I think, right? Yeah, if it's less than the minimum allowed, then in that case we will check for it in the left side of the array. And what we do to check if it's valid or not, like we take two variables. First cow will be at the very first stall, so we initialize it with the very first stall. Then we apply a for loop on the array like this, where there will be stalls in the sorted format. Then we check if array index values when we divide subtract last stall with that. Then we check if it's more than or equals to a minimum allowed distance. Okay, minimum allowed distance will be what? Minimum allowed distance will be the mid value that we have got, right? If it's true, then we will place that cow and cow plus plus, and we will reinitialize the value of last stall is equals to array of I value, okay, like array I value in that case. And we will keep checking for that the other cows will come, and in the end we will check if cows is like the number of cows we get is equals to the original number of cows. If that's true, then we will return true, and in the answer it will be stored. And we can check for furthermore bigger distances. If that's valid, then the distances will be more. Alright, this is how the code is working. And we return a answer in the end. It is a difficult medium level problem we have solved today. And also I've solved this problem today. This is also the same as this aggressive cows, okay. Like if I tell you, we applied binary search on answer, first on allocate minimum pages, then split array largest sum and painter's partition. In that, in those problems we did find the minimum of maximum, right? Like minimum of maximum pages, minimum of maximum apples, or minimum of maximum walls. But in this, the opposite of it was these variations, like aggressive cows, in which we do the opposite of that. Or take this problem, magnetic force between two walls. We do the opposite of that in these two problems. Instead of finding minimum of maximum pages or walls or apples, we try to find maximum of minimum. Okay, mean the maximum of the minimum. In this case, what we do? Yeah, distance, or here it is. Yeah, here it is also as distance, right? You can take distance or maybe time. There will be more. There are so many different variable named or just different story problems will be available. So yeah, just the variable names will change. Maybe instead of distance, it will be written as time, or maybe I think we can take as an example maybe area or something, you know. Okay, so the first revisit I will mark it as revisited. Where is it gone? Yes. And I think there is no mean that we should waste time on this more, but I will solve that problem. Revisit the second problem, which will be split array largest sum. So first problem. Okay, we I think we have enough time, right? We don't have to rush in the things. So maybe we will take new problems in a good way. So first problem, revisited. Name was I have not revisited it using writing the code, but we will write the code like so for the same for it on lead code. Okay, we have done this new problem. Oh man, we forgot to add it to the list. Wait. Just wait. I forgot to tell you the time complexity, right? Tell me the time complexity of both the problem that we have done. Every lunch is still here, man. It's happening around 9:25, right? Wait, tell me the final time complexity. Means both the problems have the final time complexity of big of n log n plus n log max distance, right? For sorting or stalls or positions, we did take n log n operations and binary search and answer distance, log, max distance, iterations. Feasibility check, it's because we did use for loop, right? Traverse the whole area. So in then I think we can say that n log n, right? N log n log max distance. Okay. Because there are functions, like we are calling a function from a function, and this function is being called by the main function. Because of that, it is showing the time complexity like that. I am also unable to understand like why the like they did not write it in simple. Can we say in simpler form as big O and log n? Yeah, and log n is for sorting. Okay, so it's showing the sorting. And log maxes binary search iterations into greedy check. Uh, okay, we can write it in a simpler form as big of n log n, right? I was thinking about that. Now we will revisit problems. Oh, first I think we will revisit that. After that, we will revisit the second problem. The revisit of second problem will be very fast because there is nothing that much to do in that, right? Mm. Oh, wait, man, wait. Mm. Mm. Well, just wait a second. Mm. Hello, hello, hello. Now I will add the code for this. We can remove this all, right? Mm. If box is more than k, we return false. If not, then true. If it's equals to k, right? We will bring it to the original position in which it was. So now we will write. So what we do first is, mm, the split array logic system. So first we write the code for binary search. Okay. So for that we get the range of possible answers by start is equals to. Uh, okay, wait. Instead of this, yeah. First we have to get the sum. Yeah, first is max. Okay, max is equals to int minimum, right? And sum. So we will get the range in that, and the sum is equals to 0, right? Now we will use a for loop, traverse the array, um, nums dot size I plus plus, and now sum plus equals to nums I values, right? So we will get all the values in that, and maximum will be the max of all the values. That will be, we will check for it if nums I value is more than maximum, then maximum we will override maximum with max is equals to nums I, that value of nums I. Okay. Now after that we apply for, yeah, now we will apply binary search. Start is equals to max and end is equals to sum. We get the range by doing this. Then after that we will apply the while binary search. Start is less than or equals to end. Then at this there will be two conditions. If is valid function that we will create will, if it's give true, if it will be true we will return its inside this we will pass these as arguments like nums and k and mid. K is equals to the number of students or number of boxes. Okay. K, then if it's this is giving true, then we will initialize answer with mid and keep checking for values, smaller values, right? because we have to return the minimum of the maximum. So mm, end is equals to mid minus 1. In that case, it will happen. And else if it's not valid, if it's invalid, in that case, we will check for it in the right side of the array. Because in that case, we will have to get a bigger value to so that the pages can be allocated in that manner. And for checking if it's valid or not, we will, oh yeah, we also have to create a answer variable, right? We will initialize it -1, and also we do have to check if before this, if nums dot size, if it's less than number of students or walls or boxes, then that case we will return -1. Okay, this is the default case. Like the number of, okay, we can assume the number of boxes is more than the number of apples. Like okay, I've named it as apples. Like 1, 2, 3, and 4, 5 apple. Okay, there are 5 apples, so we have to allocate that. Like what we do in the book allocation problem, we did if I show you, if number of elements present in the array it's less than students, okay, then that case allocation will not be possible, right? So we have done the same here, and in the end we will return my answer. In the end we will return answer. Okay, this is done. Then now we'll create another function for checking if it's valid or not. I will name it as is valid. Is valid. It will be a boolean type function, and we will also pass mid as int max allowed. Okay, I've changed the name of it. So inside this, what we do, we simply now check if the answer is like the mid value is valid or not. So we create two variables like student. Okay, we will start with the first student, and pages is equals to, no, not student banner. Yeah, we will take apples here is equals to 1, and as two boxes as 0 in the starting. Wait, did I have taken apples or boxes? Let me just see. Uh, okay, a box, one is apples. Okay, yeah, number of apples will be that, right? I was thinking about that. Yeah, first we will take the first box, and number of apples will be 0. Then after that, we check for a single case if nums maybe a single value of num size more than, yeah, if it's more than max allowed, in that case we can return false directly and say that okay, it's not valid, so return false. And also after that we do, yeah, now we will apply the for loop for I is equals to 0, I less than nums dot size I plus plus, and inside this we check if pages, okay, nums I index plus pages, if it's more than or equals to max allowed, pages. In that case, if that's true, we will do um yeah, not pages, apples, right? Equals to nums I apples plus equals to, okay. And also it will be apples, so not pages. In that case, if that's not true, then we will take another box like box plus plus, and apples is equals to current value of nums high, means on which current index it is, and also the value of the apples in that. And in that we will check if we will return if apples is then k. In that case, we will return false. In that case, we will return true. If it's in the limit, right? Like as a valid answer, it will be true. Compiler is just giving compiler undeclared number. Okay, nums are okay. We have to check it in the for loop, right? Because the pointer of it will not also increase. So mid. Okay, we forget to calculate the mid in the mid function. Mm, so start is integer mid is equals to start plus and minus start. Every time we are forgetting to calculate the mid, and that's the main part, right? But that should not happen. What? Okay, it's failing both the test cases. Hmm. Uh, what do you think? Where are the syntax error writing code for split array largest sum? Okay, but not in this. We will ask for it in the different. Syntax wise code is fine. It will compile the issue are more on logic than on syntax. All braces, parenthesis, balance, function signatures are valid. Include vector, assume syntax error there. Logic bugs, condition. What? This is normally adding nums. I wait. Correct logic. Wait, man. Why we are checking on this instead of this? We can check this function. Yes. See, this is same, right? Hmm. Okay, I got it. I got it. Maybe here. Hmm. Okay, apple. We have to write apples. Just shut up and keep your mouth shut. Just tell me what fixes do I need to have has no syntax error, but you need a couple of logic fixes that work correctly. This is Flint. Oh, why, man? Oh, okay. Oh, yeah. If it's less than or equals to, right? Mm, return condition at the end is valid. You currently checks apples count, but the real checks, oh yeah, boxes. Because we are checking, compare it with boxes, right? Boxes, oh, box. We will name it as boxes and boxes plus plus. Okay, it's passing the test cases now. We are submitted and mark it as revisited. There were just some maybe I think I forget in between just to calculate the mid, and that is a very important part. And also, but we do have understood the logic. Just okay, and I've explained you in the book allocation and the opposite of it, like what will happen. What will happen in that case, and then. mm, Okay, I think there is no more further explanation needed in this, right? Because we already did have explained the things in the day 36 stream or also in the day 37 stream, I think. So that's why I'm not giving that much uh, pressure on this, right? Hmm. Because overdoing a thing, maybe it will have diminishing returns. So because of that, we are not doing this. But and why I'm taking AI help for syntax search because just we have to save time and also go on to the next topic or problems. We also have understood it, so because of that, right? Okay, this is done. So I will mark it as revisited. So first, second problem revisited. Name was this split array, split array largest sum. And yeah, I do have to also. Do you know why I've done that? Because the problems are very similar. So that's why. Mm, I've already done this, so I will not do that. Just I have seen the lecture. And yeah, ma'am explained it in a different way. That was good, using some visuals and how the things are working. And in this case, I will do the next permutation problem. Okay, maybe in the next stream, or yeah, we can do in the next stream. And merge sorted is already been done, so we will not do that. After that, this STL video, I have to see what like the functions, right, for different type of containers and other things. It will be, I think, in a good lecture. Okay, then after that, strings is starting, right? So I want to see like what is in the strings part, and yeah, I forget to mark the aggressive cost problem as solved. So we will mark it. Yeah, solved in the binary cell. This is aggressive counts. Don't know when this problem will be solved. Its lecture is also not on YouTube. Maybe we can do this by self. We'll see that. Okay, it's a hard level problem. Don't know what happened to my throat today. So okay, now I will do the third revisit, and after that we can see and try to solve another problem, right? And I think there is not that much time has passed. We are in the limit. Just let me check if it is submitted or not. 4 minutes. Mm, Get submitted. Wait, there are 56 questions, but that should be 58. Split array as let me split this. I think we forget to add this, right? That we have to revisit. Now we are starting our third revisit of today. That's name is find first and the last position of element in sorted array. Okay, this is very simple problem. Just we have to. Okay, I was supposed to change this, right? Like the last occurrence. I think we don't have to write the code for this. Just I will revisit it in a way because it's very simpler. Like we have to find when the given target appeared for the first time in the array, and after that when it appeared for the last time in the array. Means if suppose there was target given as 8 and there were all the values present in the array was 8. Okay, all the values from the starting was 8. So we will return the index like the 0th index and the last index in that case, because 8 appeared for the first time here and also 8 appeared for the last time here. If suppose 8 was okay, all the values in between were different, so we return the 0th index and the last index, right, in that case. Okay, okay, now and we have to return those indexes in the form of a value. Okay, like I have created a vector, and suppose we are unable to find the if target is not found in the array, then we will return -1 as the index. And I've already by default reinitialized the vector values with -1, and the size of the vector is already 2, and all the values are already at -1 by default. If after doing this all we don't find the target, like at the last or the end, we will return -1 in the end, -1 and -1 as the indexes. Okay, like we don't found the starting and last index of the given target. So what we do for finding the like checking for when it occurred for the first time in the array, we simply apply a binary search taking the last first and the last value, right? We calculate the mid every time, and if suppose num's mid value, if it's equals to target, in that case we initialize override the value of the result, like the first value of result vector with mid in that case. Okay, means mid index. Okay, it will represent the index, not the value. And after that we keep searching for left. Why we do keep searching for left after this? Because okay, we found the value suppose on this point, then we keep searching for this in the left side, like going again in the left side again and again till we again found the target. So maybe if it have appeared after this also, because we are checking when it occurred for the first time. So for checking for it, if it appeared for the first time, then we have to go in the right side of the array and see if it has appeared before that or not. If it's had before appeared for that, so we will override the nums first result array first index value with that. Like instead of 4, we initialize with 3. Okay, then after that, okay, this is done. We have initialized the 0th index value of result. Okay, then after that we check when it occurred for the last time. Okay, the code is just same, and yeah, there is also two other cases, else if cases, like suppose if nums mid is less than target. Okay, because the array is sorted. Okay, if it's less than the target, then in that case we will try to find that in the right side of the array, because that value will be bigger. If that value, if nums mid value is more than target, then we will find that in the left side of the array, because we have to find the smaller value, right? And for checking the last occurrence, what we do, we just apply the same binary search again by taking the starting as 0 and end as the last index, and do all the things as same. Just here what we do, when we found that okay, it's equals to target, okay, suppose we get at this point, okay, this is equals to target, in the when we keep searching for left, we will already be on the, yeah, suppose we on the this index, it will be, its index will be in the answer, okay, we will put that in the answer, result vector first value, okay, as mid, and we will keep searching for left, but when we will keep searching, we will not again found the target, so that will be inside the result vector first value. And here what we do, when it is equals to target, suppose at this point, we mid is at this point, it is equals to target, okay, we initialize the result of mid first second value with mid, okay, but we keep searching for right in this case, because when we go in the right, maybe it has appeared after that, so when we keep searching for it in the right, we will find that it has again appeared for the second time after that, okay, on this index, when we keep searching for left and sorry right, and we will reinitialize the value of result second value with mid, and that is on the fourth index, like we will return that index as the value of result vector, right? And in the end, we are returning result like this. Just this is the problem. I think we should mark this as some revision. There is no need to write the whole code. The code is very simpler. Just we are applying simpler binary search on that. And when we found the first value, we keep searching it in the left. Maybe it have appeared before. So we go to the starting of the array, keeping searching for left. And if it has appeared before, then we will reinitialize the value, okay, when it appeared for the first time. And in the last occurrence, what we do, when it's equals to target, then after that we keep searching for the value in the right, because it may be appeared after that also in the right side of the array, means in the end of the array. If it appeared after that, we will reinitialize the value of second value of result vector with mid index, and in the end we will return the answer like this. Okay. And in the case if its target is not present in the array, we will return -1 -1, and yeah, -1 -1. Now I think we should do the third new problem of today. And time complexity of this was equals to log n, because we reduced only for loops here, and space complexity will also be big of 1, because we not copied the whole array in this, right? We just created vector, and this is different from the original vector and things. Like understood it about yesterday. It is fresh. I think that time complexity concepts will improve with time. Um, yeah, we also do have to add it in the favorite list, because I think yesterday we forget to do that, and I've also changed the comments in the code from second occurrence to the last occurrence. Now I think we should pick another new problem. Wait. Mm, minimum. Okay, wait. Um, yeah, I was thinking to pick this problem before. That's name is Steam Solve. There are, I think I've added so much problems in that, right? Maybe search in a rotated sorted array, second or binary search. Hmm. But this is not binary search will not be applied, right? Bit manipulation string. Okay, yeah, this is a string problem, not this. So uh, now I will ask it from them. Okay. Now tell me which problem should I pick next? I don't want to give so much time to a problem today because already have solved those problems which was supposed supposed to solve according to today's plan. You can give me a medium one also in which we have uh, to apply binary search. Slightly longer but still medium. Okay, so according to this we can pick. Okay, 2, 0, 1, 2. Given a sorted array of distinct integers and a target value, return the index. Okay, wait. Third problem revisit is done. What we will have to mark that also. Um, so there is a sorted array given of distinct integers and a return and a target value. We have to return the index if target is found. If not, return the index where it if it would be found if it were inserted in order. We must, okay, we use binary search. So target is 5. Okay, it should be at this index, right? In between this. Hmm. It's already sorted. We can apply binary search, but how we will do that now? I will ask it. Just tell me, like I have understood what we have to do, but what in the okay, wait, else cases where uh, target is not found. I'm thinking about it in maybe there will be some comparisons be done and some plus one things will be done. Okay. What happens when target bunny search keeps moving, narrowing down the exit? Eventually low will cross high. At that point, the insertion index is exactly where low ends up. While works, if target is smaller than all elements, okay, it gave me the code, man. Else if num_smid is less than target. Okay, yeah. Return low. Low is insertion index when not found. So how low is working in this? Low started with this. Low is equals to mid plus 1. How the code is working? If target is found, if target is not found, return the position where it should be found. Be inserted to keep the array sorted. That insert position is exactly where the loop pointer ends up. When the loop finishes, target bigger, go right. Target smaller, go left. Uh, uh, Not found plus insertion index. Returning return examples. Mid is okay. 2. Mid is at the second value, second index value. 3 here is less than 5, low. Mid 2, nums 2 is there. If it's less than target, what we do? Okay, go right. If nums mid is less than target, we go on the right side. Go right. How we have written 2 in that case? How balance? We maintain 2 pointers, low and high. Each compares target with nums mid. If mid is okay smaller, if it's smaller then we mid minus 1 means the wait. First index where target could fit. If target is smaller, then all elements low never come moves stays at 0. low, high at the end, low points to the first index where target could go. That is exactly the first, okay, insert position. Visual walkthrough target array. Targets to arrays 1, 3, 5, 6. Okay, low is the very first and last. Mid is 1. 3, yeah, it will be 1. Means the value 3. So it is more than 2. We move left, right? Okay. Mid is equals to 0. Adam's 0 value is 1. It's less than 2. Move right. Low is equals to 1. Loop ends. While the loop ends, because but why the loop ends? Okay, while low is less than or equals to high. Oh, point to the last index that is less than target. When they cross, okay. Uh, yeah, because after dividing it again and again, the search space, the value of higher will also be decreased, right? Okay, so int low is equals to 0. High is equals to nums or dot size -1. Then after that we apply binary search while start is not start, lowest than less than equals to end, right? We calculate the mid is equals to low plus high minus low divide by 2. Then after that we check if nums mid, okay, if it's equals to target, in that case we return mid, right? Yeah. Else if nums mid is less than the target, suppose it's less than the target, in that case we do check for it in the right side of the array, means start is equals to mid plus 1, and in the else case we check for it in the left side of the array, means and is equals to mid minus 1. Okay, and after that we return low, right? This was the code. Oh, not end, it will be high, and not start, it will be low. But we do have to understand how this things is a little bit how it's working, right? Less than less than equals to high, not n. Okay, man, it's accepted, but we haven't understood it yet. Low is 1, high is 0. Oh, start is this. Each step we adjust low or high, right? Eventually low becomes greater than high. That means there is no valid search range left. At that exact moment, the loop condition fails, loop ends. Example target. Start with this condition true, enter loop. Mid is equals to this, move left, high is equals to 0. Next, condition true, enter loop, mid is equals to 0. Now lower becomes, okay, we move right and low becomes 1. Now low is 1, okay, condition false. How the, okay, yeah. It's starting and end, right? So start is always pointing to the first index, points to the first index, that is more than or equals to target. Okay, more than or equals. Mm, okay. Think of loop rules. If nums mid is less than or equals to target, we move. Yeah, that means we skip all indices strictly than target, right? So we move. Okay, if this is true, nums is less than, more than or equals to target. That means we keep low where it is because the position or something before it could be the answer. So by the time loop ends, every index before low has strictly low itself is the first index where target value is value more than or equals to find. If target not found, here it's given as example. Index 0 has value less than target. Yeah. Index 1 has value more than target. Yeah. So low is equals to 1 is the correct position. How? Okay, 0. It should be between 0 and 1. So it is marking it as it should be at the one index, right? But how that's happening? Okay, because we are changing the position of low, right? Like when it's less than, then okay, we are updating the value of low, and after keeping updating that in the there will be a point when low will be more than high. Then that case we will return that as the index where it should be found, or maybe mid is equals to target. Then in that case we will return mid if it's in the array. Time complexity of the code of this will be, I think, log n, right? Because just we have used a simple binary search. Mm, third new problem. Sort name was this, search insert position. Okay, so we are in the pointer maybe, right? Low and end. as start and end. Okay. Zero, zero, zero. In the end, low is one, mid zero is high is zero, mid is okay. Loop stops, low is more than or equals to one. Okay, when we again go to check for low, then it will be okay, it will be mid plus one, right? Yeah, it will be mid plus one. In that case, low becomes higher than mid. Like start becomes more than the end. In that case, we return that value also with that index. Think of low as a marker sliding right until it finds the first element more than or equals to target. Think of high as a marker sliding left until it finds the last element less than target. When they cross, the gap between them is exactly where the target belongs. Okay, we got it. So this is done now. I think we should summarize the stream maybe. Hmm. I will say that okay, I have not done the problem by myself. Just if that's also that was not needed, right? But but today, like the problem is solved. Except that it is easy, but that understanding the code was a little bit yeah. If it would have, I think market has started and then I think we could have think about that, but it's difficult to think about that, right? So then I think we will do the revisit. It will be good and we will understand it in a better way that it is supposed to be. So what we did, we first revisit three problems, right? Oh man, we forget to code chef. Wait. First problem solved. Second problem solved. First problem allocate. Second problem. Third problem we visited. But where we solved painter's partition. Okay, wait. Let me check in my lives. It's not updated here. What problems or what were revisited and solved? Hmm. Okay, allocate painter's partition part one. Find first. Oh, okay. We also have to mark this as the revisited, right? And this is also similar as the book allocation or allocate split L largest sum problem. I just forget to do that. Like mark it as revisited. From where we will go to will again submit it like the. This is also similar to allocate minimum pages or split array largest sum. Okay. This is done. Painter's partition. Will it okay? New problems. Okay, instead of that, we revisit this, right? Allocate minimum pages. Okay, we again revisited it today, but instead of that, we were supposed to revisit this. So what I will do, um, by mistake, I revisited a problem named as hmm, named as allocate minimum pages for the third time so the first revisit was of the problem. The name was painter's partition. First problem that I revisited was painter's partition, right? Okay. So first problem that I revisited was painter's partition. After that, we can say, okay. After that, we can say, so first of all, what we did in the stream, okay, we first solved two new problems. Like first one was on LeetCode. Name was aggressive chaos. We did it. We solved it using a binary search on answer, but it is opposite of what we did in allocate minimum pages or split array largest sum or painter's partition. Then after that, I solved the similar problem to that. That's name was magnetic force between two balls. Okay, and those two new problems that we have solved today, those two are medium level problems. One was on LeetCode. Uh, one was on Geek for Geeks, like the aggressive cost problems was on Geek for Geeks, and magnetic force between two balls problem was on LeetCode, and both of these were those were medium level problems, and time complexity of both of those problems were equal to, let me tell, yeah, were equals to big of L log n, we can assume. We can assume that as big of L log n. Okay. But then after that, I revisited three problems. But by mistake, I revisited a problem for the first problem that I revisited. Like those were the same problems, but I revisited allocate minimum pages. But the concept is same. Okay, the problem is same. So I, in the end, after that, I submit this problem as revisited because the thing is same. We were supposed to revisit this. Instead of that, I revisit allocate minimum pages. So after correcting it, I will say the first problem that I revisited was painter's partition. Not painter's partition, we can say it as, okay, take it as painter's partition, okay. And the second problem that we revisited was split array largest sum and okay man, just let me see. Third problem is revisited. Second problem is third problem. Third new problem solved. Okay. Okay, there was third new problem solved also. Yeah. After the revisits, we also solved the third new problem. Okay. So the second revisit of split array largest sum and the third problem that we did. So the first, second problem and the third problem that we revisited. Okay. I can tell that man. I got a little bit confused in between. Okay. painters partition was revisited and split array largest sum was revisited. Okay, but before that, in the starting, we first solved the two new problems. Name was aggressive cows, and after that, the second problem that I solved was magnetic force between two walls. Okay, these were the first two problems. In the starting, we first solved both of those, and time complexity of both of these problem was, yeah, was big of n log n. Okay, we can assume it as big of n log n. You can see it here. Just wait, just wait. Mm, where it was thrown, man. Now I will tell you about the revisits. So the revisits that we have done was first we can assume the first revisit of as the painter's partition, then the second revisit was of split array largest sum. Okay, and also by mistake we did revisit allocate minimum pages instead of the first. It was supposed to painter's partition, so that's okay because I was thinking to explain the what is given in the opposite problem in aggressive cows and magnetic balls problem. Okay, so time complexity of the first two revisits was big of n log sum, and the third revisit that we have done was name was find first and last position of element in sorted array. We applied binary search in that, and time complexity of the third problem that we revisited was big of log n because we did just used a simple binary search in that, nothing more than that. And after that, I solved the third new problem of today. It was an easy level problem, but I will say that I have not solved it fully by myself. I used AI for that and just to try to understand what is happening. Okay, and I also think that I got to understand what we have to do. But we will again revisit in a very good way and a detailed way, and I will try to reinforce the things what is happening in that problem. It is not that much clear in my mind. Okay. And its time complexity was equals to big of log n because we reduced binary search in that, but a simple binary search. So in total, if we combine all, we can say we revisited three problems, but by mistake, the first problem that we revisited was allocate minimum pages, but again after that, I marked this as revisited, and we can say, okay, revisit was equals to 4, okay, instead of 3, we can say that, okay, the number of revisits were 4, but okay, we can assume it as 3 or 4 that we want to take, you can take that. But in the if we see in the reality, we can mark it as 3, okay? Because we just mark this as revisit. But in the reality, I think it will be 3. And today we also solved 3 new problems. And inside that, the first 2 new problems that we have solved was medium level problem, and the third new problem that we have solved was an easy level problem. And this was all. So in the end, I will say that, okay, just wait, let's see if I update this, what will happen. Okay, just wait, let's see if I update this, what will happen. It just takes a little bit of time. Mm, I was supposed to like start the stream very early, but in between I got some work. Okay, 63. Let's update it. So in the end, I will say that till then you all have to just, yeah. Before that, I will say that in total we revisited 3 problems and also solved the 3 new problems today. Okay. So in that, I will say till then you all have to just keep learning and keep exploring new things and just keep grinding. Keep grinding all of you.